We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
The introductory video for C0. And basically what we're trying to do here is we're going to find the percentile. Find the percentile. And it's pretty much the same thing we've been doing. The first thing you're going to do is go ahead and draw yourself a picture. Draw yourself that scary ghost. And then second, you're going to still use the formula, but this is where it comes different. Instead of finding the z-score, then the percent, we're just doing it backwards. We're going to get a percent, and that will help us find the z-score. And then from there, we're just going to go ahead and solve. Okay, so here are our steps. Let's go ahead and try that, for example, C1. Determine the 10th percentile of women's heights. Okay, I'm going to draw a curve here. And it tells us some facts. Calculate each percentile using the z-score table. The heights of women are normally distributed with 64 and standard deviation of 2.7. Okay. Percentiles is just meaning, you know, kind of in the word percent. Basically, we're trying to solve for that value right there, x. What is x? So this is my picture. Let's go ahead and write down our formula. Z equals x minus the mean over standard deviation. Okay, from here, we don't know what x value is. We do know what the mean is, which is 64, and we know that this one is 2.7. Okay, this is the information I need, number 3. I need to go from a percent, in this case 10%, to a z-score. So we're just going backwards. Let's go ahead and look at our chart here. And I'm looking for 10. Now, that number was to the left, so it's going to be a negative z-score. Negative z-score. Let's go ahead and do our best to look for 10%. Looking for it, and I see it over here. Try to get that out of the way. Right? There's 9.8% and there's 10%. So it's between those two values. If you go up here, that means it's between these two. So you can do something like 0.085. And then if you add that to this number, you have negative 1.2. And then you add 0.085, you're going to have negative 1.285 as our z-score. Okay? So this is our z-score. Negative 1.285. Again, I'm going backwards. I'm finding the percent, and now I'm finding the z-score. Press done, go here, and I'm going here. Okay, so 10% is basically negative 1.285. And what I do with that, so going from the percent, now I got a z-score, I put it in here. Negative 1.285. Okay? And essentially just solve for x. And to do that, I'm going to put it over 1, and I'm going to do something we did a long time ago called cross multiply. So 1 times anything And then over here, I'm going to multiply these two. Okay, I don't need that 1 there, and I don't need the parentheses, so it's just x minus 64, and I can just add 64 to all this, okay? So I have, let me take a picture of that, and then I'll put it in my calculator with you. All right, let's go to our calculator over here. 2.7 times negative 1.285 plus 64. And this will give me approximately 60.53. What does that mean? It means the 10th percentile, let's write a sentence, might help. The 10th percentile for women's height, so you can kind of use this as a sentence frame, for women's height is approximately 60.53 inches. And that's our answer for C1. Let's try C2. Let's draw a picture. And we're basically saying that all of this is representing 60%. We know that the mean in this problem is 64. We know that standard deviation is 2.7. And basically, we're trying to find out this value for x. Again, we know that this all represents 60%. So, step number 1, here's my picture. Step number 2, we need our formula. So, z equals x minus the mean over the standard deviation. We don't know what x is because we're trying to solve for that. The mean is 64 and the standard deviation is 2.7. Well, how do you find a z-score? We need to go from the percent now to the z-score. And I know it's it's 60%, but 0.60. So let's go ahead and look at our table. Okay. Now, notice how our z-score, the number was to the right of the mean or center. So it means I'm going to go to the second page and look for 60. All right. This one's a little bit too high, so not there. So it's going to be between here. So again, to go in between 5 cents and 6 cents, it's 5.5 cents. And that's this number. So 0.2 plus 0.055 gives me 0.255. A z-score of 0.255 gives me a percent of 60%. Let's put 0.255 into our formula. I forgot the number already. It's okay, you can look back like me. If I find the chart. And let's just go back. .255. 0.255. Okay. How do you make that a fraction? Over 1. And we're just going to cross multiply here. So to solve, I have 0.255 times 2.7. And over here I have 1 times quantity x minus 64. I don't need to write 1 in parentheses. And I can just add 64 over here to both sides. Let's put that in our calculators. And on my calculator. Here it is. 64 plus 0.255 times 2.7 gives me 64.6885. What does this mean? The 60th percentile of women's height is approximately 64.69 inches. And this is my answer for C2. Let's move on to C3. Determine the height that separates the top 10% of heights from the rest. Okay, let's draw a picture. And now they want top 10%. So they want something like this, really tall people. And this here represents 10%, right? From a percent to a decimal. And we're trying to solve what is x. So this is my picture. Let's get the formula. Z equals x minus the mean over the standard deviation. The mean has been 64. And the standard deviation is 2.7. Let's plug that in. So we're still trying to find x. The mean is 64. Standard deviation is 2.7. And now we basically need to go from a percent to a z-score. Okay, pay attention now. Pay attention. If this blue region is 10%, how much is this yellow region? Right? We've done this before. Yellow plus the blue equals 1. Yes? If blue is equal to 0.10, if you subtract 10 cents from $1, you'll get the yellow to be 0.90. Why is this important? Because you're not looking up 0.10. You're not looking up 0.10. You're looking for 0.90. 0.90. Let's look for that in our chart. Okay, I'm on the right side of the mean, or the center, which means I'm going to use positive z-scores. So 0.90 here and here. So 0.8159. 0.815, 81594, 81594, 81594, 81594. And then we're just going to put this over 1, and we're going to cross multiply. And again, when you multiply this, it's just 1 times the quantity. So it's really just x minus 64. Add 64 to both sides. And here's my calculator ready equation. Let's do that together. Let me take a picture so that I can put it in there with you. So 64 plus 2.7 times 0.815, 94. And the calculator is doing order of operations. 66.2 66.2 is our answer. So we can say for C3, the height that separates the, just copying that, top 10% of heights from the rest is 66.2 inches. And that's my answer for C3. Let's go ahead and look for on our table as on the Z-score that gives us that 90%. So let's go over here. %, or the x value that I was trying to find, is to the right of the mean. So I'm going to use a positive z-score, not a negative. Let's go ahead and find 90% on here. I think I'm pretty close. Let's see. I think it's better over here. Between these two numbers. So 0.085, because that's like a 0.090, so 0.085 to 1.2. So I have a z-score of 1.285. A percentage under the curve of 90% is equivalent to a z-score of 1.285. 1.285. And then we're going to cross multiply here in blue. 2.7 times 1.285 equals 1 times the quantity x minus 64. When you have 1 times anything, you don't need the parentheses or the 1. So I just add 64 to both sides. And I have my calculator-ready equation there. Let's do that one together. (64) plus 2.7 times 1.2875. I forgot the number again. 1.285, that was correct. Delete. Okay, and you will get a number here, 6747. 6747. The height that separates the top 10% of heights from the rest is 6747. Because guys, if you think about this backwards, you can actually use your calculator. If you used our last video, you can use plums, right? This is your lower. This is your upper. You have the mean, you have the standard deviation, and if you put that into your calculator, 67.47, you will get that yellow area to be 90. All right, let's do one more. C4. Determine the women's height that would separate the shortest. Okay, where do you think the shortest would be? 1% of heights. Short people are to the left. And we're saying that this green area, this green tail they call it, is 0.01. Okay, and we're trying to find out that x. So here's my picture. Let's get our formula. Z equals x minus, we're trying to solve for that x value. And let's just plug it in. X we don't know. The mean is 64 and the standard deviation is 2.7. I'm going to have to figure out from a percent to a z-score of 0.01. 0.01. 1% is 0.01, so let's look for it. Now, it's the tail, that shaded area is to the left of the center, which means it's going to be a negative z-score. So let's go ahead and find 1%. 0.01. 0.01. I am still looking, and I found here. So you can use between these numbers, right? You can add zeros there to help you make sense of it. It's kind of like 0.0 and then 20, 0.0 and then 25, then 0.0 and then 30, so 0.025. And that's negative 2.3. And that number over here was 0.025. Okay, let's summarize what this means. A 1% is equivalent to a z-score of negative 2.325. A percent under the curve of 1% is equal to z-score of negative 2.325. So, which means that you put that over here. So 1% is a z-score of that. So you just put it over here. Put it over 1, and then you can just cross multiply. You want to do that in black. And let's go ahead and put that into our calculator. And we get 5772. 5772. And then we can just write that sentence. The women's height, so that's x, that would separate. I'm just copying that sentence up there. The shortest 1% of heights from the rest would be 57.72 inches. So x we basically found to be 57.72. Okay, so that was C4. All right, let's go over C5. Directions 3, calculate each percentile using a z-score table. The heights of women are normally distributed with a mean of 64 and a standard deviation of 2.7. All right, let's draw a picture. There is our center. And this little bit of information says 45%. Now we know that if the whole curve is 100%, if you divide it in half, that means it's 50-50, so 45th percentile would be something like this. They're basically wanting to know what is this score that corresponds to this x value that gives us a 45%. Okay, let's go ahead and use our formula. Z equals x minus the mean over the standard deviation. We'll substitute in the information we have. X minus the mean was 64, standard deviation of 2.7. And then here I'm going to use my percent into a z-score. And basically what we do is we're trying to figure out how to find 45%, which is 0.45. So let's go ahead and go to our table and look for 0.45. I want you to notice that 0.45 is in the z-score that's negative because it's to the left. So I'm on the negatives here. Let's look for 0.45. Getting close, maybe over here. Alright, this number over here looks pretty good. So this is negative 1.6, and we go up 0.09. So that means a z-score of negative 1.69 is basically equal to 45%, or 0.45. So let's use that z-score of a negative 1.69. That's 4%, not 45%. Okay, let's take a look. Alright, 45% is somewhere over here. So negative 0.1, and I'm going to go between these. I knew something was wrong. 0.025. And they're both negative. So negative 0.125. That's the z-score I need. Let's try that again. At least I caught my mistake. That's a good thing. All right, let's try that again. So negative 0.25, and I should have done some number sense. That number is actually close to 0, which was close to the mean, right? A mean, right in the middle, that means your z-score is actually right on the dot too. And if I add that to 64, I get another number. Let's take a look. Negative 1.25. Let's try that again. Negative 1.25 times 2.7 plus 64 should give me 6366. That was correct. Okay. So x equals 6366. What does this mean? The height and then I'm just copying that for the 45th percentile for women's height is 63.66 inches. And this is our answer for C5. Let's go on to C6. The doctor has determined that a girl will probably be in the top 4% of women's height when she is grown. Determine the minimum height the doctor would predict for the girl when she is grown. So let's do a picture. And basically this green area is 4%. That means this area is 96%. And we're trying to find this x value. Let's use our formula. Z equals x minus the mean over the standard deviation. And we get the x score we're trying to solve for. The mean we get from at the top there in direction number 3, so mean of 64 over 2.7. And now we need to figure out the percent to a z-score. So we're looking at 4%, which is 0.04. Let's go take a look at our table over here. And I'm looking for 96% on the right, so that means the z-score would be a positive. And I'm looking for this one right here. So if that is 50, 50, so 0.055 and 1.7. Okay, so a z-score of 1.755 basically gives us a area curve under the curve to be about 96%. 1.755. Alright, just put up for 1 and then cross multiply here. And then if we add 64, remember PEMDAS means you multiply first. I'm just going to do my handheld calculator here. Okay, this would give us a height of 68.74 inches. So that means the girl probably be taller than, right, because she'd be in the 4%. She could be higher than that. Approximately how tall did we find out? 68.74 inches. And that is our answer for 6C. See you guys.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today.